These days those lines are blurred because we have layer 3 switches, but in simple terms, a router will transmit packets and a switch will transmit frames. Now in the real world, a lot of networking engineers do not use the OSI model in its purest form or original form. Network engineers tend to concentrate on the lower 4 layers of the OSI model. Now that's changing again with the rise of virtualization and technologies such as VMware, but it's still true for many network engineers. So in its purest form, the OSI model has 7 layers. The application layer at layer 7, all the way down to the physical layer at layer 1. This model, however, was not originally developed for TCPIP. It was originally developed for protocols such as CLNS and CLNP, or Connectionless Mode Network Service and Connectionless Mode Network Protocol. Don't worry too much about these protocols. Unless you're using a routing protocol such as ISIS, you're probably not going to encounter these protocols if you're not using ISIS. TCPIP had its own model, which consisted of the application layer, the transport layer, internet layer, and network access layer. As you can see here, the top 3 layers of the OSI model are grouped into a single layer. So application, presentation, and session are grouped as a single layer called application. The transport layer is equivalent, and the network equivalent is known as the internet layer. The data link and physical layers are grouped together into what's called the network access layer in the TCP/IP model. Now, in the real world, we tend to use a hybrid of both of these models. So you'll often find that network engineers group the application, presentation, and session layer into the application layer, but they will still refer to the transport, network, data link, and physical layers, which are part of the OSI model. They'll even refer to this hybrid model as the OSI model sometimes. The reason for that is that most network engineers still tend to spend most of their time looking at the lower 4 layers of the OSI model, and thus the top 3 layers are grouped together into a single layer known as the application layer. Network engineers tend to concentrate their time and efforts on getting information from one host to another host, rather than being concerned about what happens when the data gets to that host. The higher layers of the OSI model may still be the realm of the developer or server admin, and thus a lot of network engineers will use the hybrid model but still refer to it as the OSI model. So just be aware that we have the pure OSI model, we have the TCP/IP model, and then we have this hybrid model. However, because of the growth of VMware, a lot of network engineers are having to work with all the layers of the OSI model. So this may not be true in your environment. You may have to troubleshoot applications as well as network infrastructure issues, whereas some engineers never get involved with application troubleshooting. They spend their time working with routing protocols as an example. Another important concept to understand is that when host B receives traffic, it needs some way of differentiating protocols used at the higher layers of the OSI model. So as an example, host A may be sending telnet traffic to host B, and at the same time may be sending TFTP traffic to host B. How does host B know which of these applications the traffic belongs to? You could have telnet traffic mingled with TFTP traffic. So the PC may receive 10 packets. The first 3 packets could be TFTP. Then there may be 2 packets of telnet traffic, and then 5 packets of TFTP. How does host B know which application to forward the traffic to at higher layers? Host B may also be running multiple layer 3 protocols. So as an example, it may be running IP version 4 as well as IP version 6. How does host B know whether the traffic arriving at layer 2 is IP version 4 or IP version 6? So when the bits are received at the physical layer of the network interface card of the PC, it will read the layer 2 frame at the data link layer, and in that frame, if it's using Ethernet 2, which is the most common type of Ethernet, there's a field called the type field that denotes or specifies the higher layer protocol. So the network interface card will read the type field. The type field informs the network interface card whether the traffic is IP version 4 or IP version 6, or perhaps some other protocol such as ARP. So the type field informs the device which process to send the traffic to at higher layers. So it could be IP version 4 or could be IP version 6. At layer 3, the protocol number informs the device which protocol is running at layer 4. The two most common protocols are TCP and UDP. So at the network layer, the protocol field specifies the layer 4 protocol, and at layer 4, the port number specifies the application that's being used, which could be Telnet, TFTP, HTTP, and so forth and so on. So as an example, Telnet uses port 23, TFTP uses port 69, and HTTP uses port 80. But there are many other well-known port numbers. It's well worth learning some of the well-known port numbers to help you in your networking career.